So in this lesson we're going to look at force. So basically force is a quantity and a force causes an object to move, change direction, speed up or slow down. We measure force using this unit called a Newton. So we measure force in newtons. So N, this letter N stands for, it's abbreviated for Newton. So to think about like a force, for example, gravity is a force that pulls objects down towards the earth. So if we take the force of gravity on the earth, for example, that is a force that keeps us, that's acting on our body all the time, that's keeping us attached to the earth. Likewise as well, if you take the sun, for example, it's a huge body, has massive mass, and it's exerting a force of gravity on the earth, and it's causing the earth to rotate around it. So therefore the sun is also exerting a force of gravity. So gravity is a force. Now another force as well is friction. So friction is the force that opposes motion. So if something is in motion, for example, if you roll a ball on the ground, that ball will be in motion, it'll move, but what will cause it to slow down and to eventually to come to a stop is this force of friction that is acting in opposition to the motion of the ball. So thrust is a force caused by an engine that causes movement, such as the upward thrust from a rocket engine. So for example, like a rocket engine, if you take like a spaceship that wants to move a rocket, for example, the force of the engine, that's like thrust force, and it'll cause it to work against the force of gravity on the earth and to be able to get out of the earth's atmosphere. So upward thrust in a rocket is caused by the expulsion of combustion fumes in the opposite direction of the rocket. Okay, so you can think about it like a force that's acting on the object. So basically, if we take like any object really, and let's say we take in this case like a press. So if we want to move that press, we have to exert like a pushing force on it. So we have to exert a force, and what that will do is it will cause whatever you're exerting the force on, if there's enough force, it'll cause it to start to move or to go into motion. So once it starts to move, it's in motion. Now the minute, for example, this person starts to push the press across the floor, what's going to happen is you're going to have a force that's working in the opposite direction called friction. So friction is a force really that, like, what happens is, so if you were to zoom in, let's say, to the boundary between the press and the floor here, this is kind of like what it would look like on the microscopic level. So for example, if we're pushing in this direction, what will happen is, because the floor is not perfectly smooth, there's going to be like, it's going to get snagged and caught, and there's going to be a force of friction acting against the force of motion on the press. So what that does is it causes the object to slow down. So that's the way. So what's happening is, when you have two surfaces interacting like that, you're always going to get this force of friction. So if you were to take this same floor and you were to, let's say it was on an ice skating ring, so what happens there is that the surface of the ice, for example, is way smoother than this surface here. And what will happen is there will be very little friction, so it'll be much easier. You'll have to apply less force in order to move this particular same object across, for example, an ice skating ring. So that's the force of friction and this force of motion. So again, force causes an object to speed up, slow down, or change direction. So weight then. So the weight of an object is the force of gravity acting on that object, which depends on its mass and also on the acceleration due to gravity, which is 10 meters per second. It's actually 99.81 meters per second. So what that means is that the Earth's gravity, it causes objects to move. It has a force. It causes the objects to move it accelerates objects at 9.81 meters per second per second. So for example, if we, like, weight then is a measure of force acting on a particular mass. So what you have is, you have the mass of the object, which is measured in kilograms, and then when you put that object in, like for example, if you hold it up in the air, what's going to happen is the force of gravity is going to be trying to pull that object down towards the earth. So, and that force is going to be measured in newtons. So weight, so a lot of times people get weight and mass mixed up. So weight is actually the force of gravity that's acting on a particular mass. When you step on a scales, what you're measuring is you're measuring your mass. So weight is different on different moons and planets because the acceleration due to gravity is different. And the reason why gravity, the force of gravity, is different on different planets is because of the size of the planets and the mass of the planets. So the bigger the mass of the planets, the stronger the force of gravity. So weight in kgs. So if we want to work out what the force or what the weight of an object is, and remember that's going to be a measure of force, what we can do is we can take the force of gravity on Earth. So if we're talking about objects on the Earth, and we can round this up. So it's 9.81, but we can round it up to 10 meters per second. So if I want to work out, for example, what the weight of a mass is, I take that mass and I multiply it by 10. So for example, if we take this object here, so this is a weight and it has a mass of 8 kg. So if I want to work out what's its weight, I multiply this by the force of gravity, which is 10 meters per second, and that's going to give me the weight in newtons. So it's going to be 80 newtons. So what is the weight of an object that's 8 kg mass on an Earth? So what is the weight of it? So we take that 8 and we multiply it by 10, and it's going to be 80 kg is its weight. So to calculate the weight of an object on different planets, multiply the mass, which never changes, by the acceleration due to gravity for the planet. So different planets will have different forces of gravity, and in order to get the force of gravity on a particular mass, you multiply it by whatever the force of gravity is for the planet or moon or whatever it is that you're measuring the weight on. So to get the weight of any object on the Earth, for example, you take its mass and you multiply it by 10, and then that will give its weight in newtons, like this example here that we looked at. So again, like we mentioned, if we take an object like this, like a block, what we can do in order to make that block move, we have to apply a force to it. So if, for example, we can apply a pushing force, which would push the object, or we can apply a pulling force. Now what we can do is we can actually, and what happens then is you get this, for example, you get the force of gravity, which is acting on the object, keeping it attached to the table in this case. And then you will also get the force of friction as well. That's going to act in opposition to the push or pull force. So the force required to move an object can be measured with a spring balance or a Newton meter. So it's this object, it looks something like this, and we can attach it onto the object that we want to move. And what we can do is we can pull it, and it'll give us a measure of the number of newtons that we have to apply to the object in order to get it to move. So friction is the force which opposes motion. So in this diagram, a pulling force of 4 newtons is enough to overcome the friction and move the block. So for example, if we apply a pulling force of 4 newtons in this case, it's enough to overcome the force of friction and also the weight of the block as well. So there's 6 newtons acting, pushing the block down or pulling the block down towards the earth or pushing it against the table. And then what we can do is we can overcome that force by applying 4 newtons. So the force of gravity pulling it down, there's an equal and opposite force that's pushing up on the object as well, which is 6 newtons. So that gives the object, like that makes the object, you have, like, for example, a table that's pushing back up against this object, and the force, the push down force or pull down force when gravity is equal to the force that's acting in the opposite direction from the table. So as a result of that, the block will just sit on the table. If, for example, the force, like this was a massive block, was very heavy and the force was extremely strong and it wasn't equal to the upward force, what would happen is that block would go through the table and, smash through the table as well. So when we're measuring force, we use this object called a Newton meter, and a Newton, so force is always measured in newtons as well. So if we want to get the weight of an object or the force acting on an object in the Earth's gravity, we multiply the mass by 10. So that is force, and that's how we measure force.